Good morning. I am Dr. A. Kalai Selvi. Today I present the topic forward chaining and backward chaining. Here, forward chaining, it is a form of reasoning which starts with input data fact in the knowledge base and applies in the rules in the forward direction to extract more data until a goal is reached. When decision is taken based on the available data, then the process is called as forward chaining. Then the properties are, it moves from bottom to up, that is bottom to top. It is a process of making a conclusion based on the known fact or data by starting from the initial state and reaching the goal state. It is otherwise called as data-driven approach. Forward chaining is used in the expert system. The next one is backward chaining. A backward chaining algorithm is a form of reasoning which starts with a goal and works backward. Backward chaining through the rules to find the known facts that supports the goal. That is, the properties are, it is known as top-down approach. That is, it is from top to down. In the backward chaining, goal is broken into sub-goals and sub-goals to prove the facts. It is otherwise called as goal-driven approach. The backward chaining is otherwise known as goal-driven approach, in which a list of goals decides which rules are selected and used. That is, the figure for this is data, rules, then conclusion. First, the given data are A is equal to 1 and B is equal to 2. The rules is if A is equal to 1 and B is equal to 2 is one of the rule. Another rule is if C is equal to 3. Then if the rule is satisfied, then part is executed. If the first rule, if A is equal to 1 and B is equal to 2, then if it is satisfied, then execute C is equal to 3. C is equal to 3 is the conclusion. Suppose if C is equal to 3, if it is true, then D is equal to 4. This is the conclusion. This is the figure. So it is the forward chaining from the beginning to end. That is the example of forward chaining given a rule-based chaining following rule sets. Rule 1. If A and C, then F. That is, if A and C are true, then execute the part F. Then rule 2. If A and E, then G. That is, if A and both A and E are true, then execute the part G. The rule 3. If B is true, then execute the part E. Rule 4. If G, that is execute the part, if G is equal to true, then execute D. Problem proof. If A and B true, then D is true. Solution. Start with input given A, B true and then start rule 1 and go forward. First iteration to fourth iterations. This is also already explained. The next one is backward chaining algorithm. Backward chaining is a technique for drawing inference from rule base. Backward chaining inference is often called goal-driven. The algorithm proceeds from desired goal, adding a new assertions found. A backward chaining system looks for the action in the then class of the rules that matches the specified goal. That is, goal-driven, the data and the rules and the conclusion. It starts from the conclusion, then apply the rules, then find out the data. That is, it backwardly find out the data. So if D is equal to 0, then the rule is if satisfy the rule, C is equal to 3 and the values are A is equal to 1 and B is equal to 2. That is the reversely executed. So it is called a backward chaining. Given rule base contains the following. Rule 1, if A and C, then F. Already given. Rule 2, if A and E, then G. Rule 3, if B, then E. Rule 4, if G, then D. Prove if A and true, then D is true. Solution: start with goal is D is true. Go back. The rule fires is found. Thank you.